many of us have CAD files or maybe even old paper drawings that we've had in our company and we've had in our businesses, and we not just rely on the drawings, but we rely on the field notes and the information that was collected to resolve those boundaries to help us in today. And that's one of the huge powers of GIS out of the box, is having your legacy data, the old data, the jobs that you've done a year ago, 5 years ago, 10 years ago, that are probably adjoining some of the jobs that you're doing right now, or at least they're near there. Being able to access that data is a huge value when you're using GIS to manage your business. And what we're going to show you right now is the same area that we used 090901 as far as the sample project area, which is a subdivision right near our office in Corpus Christi. Right now you're looking at that subdivision, and there are points that we measured in that subdivision, iron rods, as well as we established a 60D nail. Went out there originally, we set up a 60D nail and set a total station on it, and we backsighted a point of curvature, which was the farthest point from the instrument, and then we used assumed coordinates, 5,000, 5,000, like so many of us surveyors do, so that we could show you how to get some of your assumed data onto grid. After turning angles and distances, coming up with relational relational distances and relational coordinates differences between the iron rods of the different lots and the subject lot we were surveying. Then we went out and we took the 60D nail, and instead of 5,000, 5,000, which was the starting coordinate, we utilized the OPUS solution that gave us a brand new coordinate value of a lot larger number than 5,000, 5,000, and we used that to actually bring the CAD file. And in this case, the CAD file that we're going to be bringing in, and again, Will Herring's working with me. He's going to be driving the computer here. We're going to be bringing in a CAD file that is the actual subdivision that he COGO'd in. And the actual CAD file that he COGO'd in also has the 60D nail in it, and it's all based on assumed coordinates. So when we bring this, we can use the Add Data button, which in ArcView we have the little yellow black box, the plus in it, and we can import the actual CAD file. So we're going to hit Add Data, we're going to go down to where that drawing is, the subdivision drawing, and we're going to import that into our job. And when we do that, it's going to give us a little warning box, or it should give us an error, because that original coordinate file is not going to be even a mile or two, or even a couple of miles. It's going to be about 3,000 miles from our actual project.
That's right.
And so once that drawing file comes in,
we can go ahead and open up the properties for that CAD layer.
oh, okay, yeah.
And there you go. And it's showing you right here. There's going to be let's see, 5 different, I guess, sublayers, if you want to call it, to a CAD drawing. You have, annotation, point, polyline, polygon, multi-patch. It doesn't really matter which one of these you have selected right now. It's just letting you know that they're there.
Okay.
So from here, what you're going to want to do is go ahead and open up the properties, and you can see up at the top you're going to have a couple different tabs to choose from. Make sure you have the transformation tab.
That's the one on the far right?
You got it.
Okay.
And first thing, you want to be sure and have this enable transformations box checked on, otherwise what you're going to import is not going to work.
Oh, okay.
It's just not going to do it. So from there, you're going to want to hit this rotate, scale, and translate.
Okay.
And that's going to take you, you're going to have, you see you have from XY to XY. So that's where you're going to take the 5,000, 5,000 and convert it to the coordinates that you want it to be set.
Right, because the X and the Y are the same, 5,000 and 5,000, and we want to take the 5,000, 5,000 from, and we want to use our keyboard and enter the correct X and Y values based on what Opus gave us back.
Exactly. So for the from X, we're just going to go ahead and enter it 5,000. And the same for the Y. It's gonna, 5,000, 5,000 is going to be all the same. And the new coordinates are going to be entered in under the 2 section. So we'll go ahead and enter in the new X for that.
So that's 134 decimal. I mean, no, 134.0090 decimal 586.
Okay.
And the Y value, which is a northing, is 171.50667 decimal 012.
Okay.
And as far as the angle, we're going to leave it at 0, and we're going to leave the scale factor at 1. And the reason we can leave the scale factor at 1 is because right here where we're working, the scale factor is pretty much 1. There is not much difference between grid and surface here in Nueces County at this particular latitude and longitude. And whenever you hit OK,
Yeah, you can hit apply first.
oh, I'm sorry. Yeah, you have to hit apply, then OK, and then what happens? Will step us through.
Go ahead and hit OK again.
All right.
And it automatically shifts everything up. So now you can see this. The CAD file that we imported is now georeferenced to the right location.
Awesome.
And that's about it.
Right. And here's a point where we used one point, only one point, and we applied grid coordinates to it, and we're able to bring in multiple points that were on an assumed basis, but we're in part of the same CAD file, and bring that in to our GIS to add a lot more value next time we do a job in this area, and as far as job prep and as far as knowing where we've been. So GIS out of the box, as far as georeferencing, for those of you that are going to be using total stations and GPS, which is pretty common. Many of us are trying to do whatever we can to be billable. And for those jobs that you're not going to get to with your RTK, or you can't, then we recommend that you get back out there and either use RTK to get some state plane coordinates on a corner or two, or go back out with the GPS equipment with 2 receivers or 3 receivers and get them out there going and collecting 15-minute sessions so you can use the NGS Opus function.